welcome to a deep dive, a deep dive into something that's really got scientists kind of scratching their heads.
Oh, yeah.
Dark energy.
Yeah.
We're going to try to, untangle the science behind this elusive force that is, pretty much shaping the fate of the entire universe as we know it.
Big stuff.
And we've got some really great sources for this deep dive today.
Yeah.
We've got some articles from NASA. We've got some insights from the Rubin Observatory's website, even a little bit of Wikipedia in there, too, just for good measure.
Nice. A good mix.
Yeah.
So, I mean, it's a fascinating puzzle, right? I mean, we've got this universe expanding, ever outwards.
Right.
And then, boom, we discover it's not just expanding, it's actually accelerating.
Right.
That's where dark energy comes in.
Exactly.
And it really does, change the whole game.
Yeah, I was reading that NASA article.
Yeah.
About all the different types of stuff in the universe, right?
Mm-hmm.
Dark matter and dark energy. And they were saying that matter, the stuff we can actually see and interact with.
Or the stuff we know.
Yeah, only makes up about 5% of the universe.
Yeah.
That just blows my mind. What about the other 95%?
Yeah, well, so about 27% of the universe is dark matter.
Okay.
And we can't, see it directly, but we know it's there because of the way it affects the movement of galaxies.
Oh, okay.
But, the real showstopper here, I think, is dark energy.
Yeah.
Which makes up a whopping 68% of the universe.
Oh.
That means the majority of the universe is made up of something that we barely understand.
That's wild. But how did we even figure out that this dark energy stuff exists?
Right.
It's not like we can just point a telescope up at the sky and be like, oh, there it is.
You're right. It's not that simple.
No.
It all started with the discovery, that the universe is expanding.
Right.
Which itself was a revolutionary idea back in the day.
Yeah.
Astronomers like Henrietta Swan Leavitt and Edwin Hubble,
Oh, yeah.
they played a really crucial role in this whole discovery.
I remember reading about Leavitt and her work with the Cepheid variables.
Yeah.
She figured out a way to use these special stars as like standard candles.
Yeah.
To measure distances in space.
That's right.
It's incredible how these stars helped us to unlock these big secrets of the universe.
Yeah, it really is incredible.
Yeah.
And then, Hubble, he built on that work.
Okay.
Observing that the farther away a galaxy is from us, the faster it's moving away.
Interesting.
This observation led to what we now know as Hubble's law, which basically tells us that the universe is expanding,
Right.
like a giant cosmic balloon.
So the universe is expanding.
It is.
But wouldn't we expect that expansion to slow down over time?
Yeah.
Because of, gravity should be pulling everything back together, right?
That's exactly what scientists initially thought.
Yeah.
But then in the late 1990s, two teams of astronomers,
Okay.
they were studying distant supernovae, and they made a startling discovery.
Right.
These supernovae were dimmer than they should have been based on their distances.
Okay.
Which means they were farther away than expected.
So it's like the universe hit the gas pedal or something.
It's a good way to put it.
It's not just expanding, it's accelerating.
Yeah.
That must have been like a huge shock to the scientific community.
It absolutely was. It earned those scientists the Nobel Prize in Physics in 2011.
Wow.
Yeah, and it really forced everyone to rethink, our whole understanding of the universe.
Wow.
And it led to the hypothesis of dark energy,
Right.
this mysterious force that's counteracting gravity
Right.
and driving this accelerated expansion.
So this dark energy really is a game changer.
Yeah,
It completely changes our understanding of the universe's past, present, and future.
absolutely.
But what's really fascinating to me is that we still don't know what it actually is.
Right. We know it's there. We know what it's doing, but we don't know what it is.
Yeah.
The NASA articles we have,
Yeah.
they dive into a few of the leading contenders
Oh,
for what dark energy could be.
Yeah.
And, they range from the mind-boggling to the downright bizarre.
Well, let's unpack those theories.
Oh.
I'm ready to dive into this weird and wonderful world of dark energy candidates.
Let's do it.
All right.
Okay.
So we've got this mysterious force pushing the universe apart.
Right.
But what could it be?
Yeah, that's the million-dollar question.
The NASA articles mention something called vacuum energy.
Yeah.
What in the world is that?
Well, it might sound like science fiction.
It kind of does.
It does,
Yeah.
but, it's a serious contender in cosmology.
Really?
Imagine this. Even seemingly empty space,
Mm-hmm.
the vacuum,
Yeah.
it's teeming with activity
Really?
at the quantum level.
Wait, so you're telling me that empty space isn't actually empty?
Not really.
Yeah.
What's going on down there?
Well, according to quantum field theory, even the vacuum is filled with these virtual particles.
Virtual particles.
Yeah, they just pop in and out of existence,
Wow.
constantly interacting and creating energy.
That's amazing. It's mind-boggling, I know.
It is.
But that's the quantum world for you.
Right.
It's a strange place.
So these virtual particles, with their very short lifespans, are somehow contributing to this repulsive force that we call dark energy.
That's the idea, yeah.
That's pretty wild.
It is, and it gets even wilder.
Oh, no.
Yeah.
Okay.
If we try to actually calculate the amount of vacuum energy
Right.
based on our current understanding of quantum mechanics,
Uh-huh.
we get a number that's astronomically larger
Okay.
than what we actually observe.
Like how much larger are we talking?
Like 120 orders of magnitude larger.
120 orders of magnitude.
Yeah.
So our calculations are a little bit off.
Just a tad, yeah.
Okay.
This discrepancy
Yeah.
is known as the cosmological constant problem.
Oh, wow.
It's one of the biggest head-scratchers in physics.
Really?
If vacuum energy is indeed dark energy,
Yeah.
then there must be some unknown mechanism suppressing its effects,
Right.
keeping it from completely overwhelming the universe.
So it's like the universe has some kind of safety valve or something
You could say that.
that's preventing this vacuum energy from just going crazy.
Right, exactly.
But the NASA article also mentioned another possibility,
Yeah.
something called quintessence.
Yeah, quintessence. That's a fun one.
What's that all about?
Well, quintessence proposes that dark energy isn't this constant force,
Okay.
but rather it's like a dynamic field
Uh-huh.
that can change over time and space.
Oh, so instead of a steady simmer, we've got something more like a cosmic weather system
That's a great analogy.
with energy storms and like shifting patterns.
I like it.
Okay, cool.
This dynamic nature of quintessence
Yeah.
could help explain why the universe's acceleration started when it did.
When was that?
About 5 billion years ago.
Okay.
If dark energy were constant,
Right.
the acceleration might have begun much earlier.
Okay.
And that would have prevented the formation of galaxies and stars as we know them.
Interesting. So quintessence could solve that why now problem.
It could.
But it also introduces new mysteries,
Ah.
right?
Of course.
Like what this quintessence field is made of, how it interacts with other forces.
Absolutely. It opens up a whole new can of worms.
It does.
Yeah, it's a very exciting area of research.
Yeah.
Because it just, poses so many new questions. We're still in the very early stages of trying to understand quintessence,
Yeah.
but, it really does have the potential to unlock some deep secrets about the universe.
This deep dive is getting more and more intriguing.
Oh, yeah.
We've got vacuum energy, we've got quintessence, and then we've got these other even more out there ideas
I know.
like cosmic strings,
Yeah.
or that maybe our whole understanding of gravity needs a total overhaul.
I mean, those are definitely some of the more radical possibilities,
Yeah,
but they just highlight how wide open the field of dark energy research really is.
it really is.
Like cosmic strings, for example. Those
Yeah.
are these hypothetical one-dimensional defects in the fabric of space-time,
Okay,
like cracks in the universe.
cosmic cracks.
Yeah, I know. It's wild.
That's an image that'll
Yeah.
stick with you.
Definitely.
But what about our understanding of gravity being flawed?
Right.
Are we saying that Einstein got it wrong?
Well, not necessarily.
Right.
Einstein's theory of general relativity.
Right.
It's been incredibly successful at explaining a lot of phenomena.
Sure.
The bending of light around massive objects,
Yeah.
the existence of black holes.
Yeah.
But it's possible that our current understanding of gravity breaks down on cosmological scales.
So it could be that the very laws that govern gravity need some tweaking
Possibly.
to account for this accelerated expansion we're seeing.
That's one way to look at it.
That's a pretty big deal.
It is. It's, really a testament to the scientific process.
Right.
Constantly questioning assumptions,
Yeah.
looking for more complete explanations.
Right.
Some scientists believe that modifying our theory of gravity
Uh-huh.
could actually explain the observed acceleration
Well,
without
yeah.
even needing dark energy at all.
So we either have this mysterious invisible force shaping the universe,
Yeah.
or our fundamental understanding of gravity needs a rewrite.
It's one or the other.
What a conundrum.
It's a big one.
It is.
But here's the exciting part.
Okay.
There's a whole wave of new research and incredible tools
Oh, yeah.
that are on the horizon
Cool.
that could really help us solve this puzzle.
I was just thinking about that. The Rubin Observatory website.
Yeah.
That got me really excited.
Yeah.
It seems like they're building the ultimate dark energy detective tool.
I think that's a fair assessment, yeah.
Okay.
The Rubin Observatory, which is under construction in Chile,
Right.
it's going to be the world's largest astronomical camera,
Wow.
capturing images of billions of galaxies in incredible detail.
It's really going to create this incredible 3D map of the universe,
Yeah.
tracking how galaxies cluster together over time.
It's amazing.
It's like we'll have a front row seat to this cosmic dance choreographed by dark energy.
Yeah, it's going to be really cool.
And they're even going to use citizen scientists to analyze all that data
Right.
with the Dark Energy Explorers project.
It's a great project.
Yeah.
It's a remarkable undertaking.
It is.
By studying these large-scale structures,
Right.
we can gain insights into the distribution of dark matter and dark energy.
Oh, okay.
And then by observing thousands of supernovae,
Yeah.
we can refine our measurements of the universe's expansion history.
It's really cool. It's amazing to think about how much we're going to learn in the coming years.
Oh, yeah.
But shifting gears a bit,
Okay.
I was reading in that NASA article about the potential implications of dark energy
Yeah.
for the future of the universe.
Right.
It paints kind of a lonely picture, doesn't it?
It does. If dark energy continues to drive the universe's expansion at an accelerating rate,
Right.
it's possible that most galaxies will eventually be pushed so far apart that they become isolated islands,
Wow.
in the vastness of space.
So we could be heading towards a future where our night sky is almost completely devoid of stars.
Potentially, yeah, with only the faint glow of a few nearby galaxies remaining visible.
That's a pretty bleak thought.
Yet a bit bleak.
Yeah, and if dark energy proves to be even more dynamic and powerful
Right.
than we currently understand,
Yeah,
things could get even more dramatic.
they could.
That's where that quintessence idea comes back into play, right?
Right.
If dark energy isn't constant,
Yeah.
but rather something that can evolve and change over time,
Yeah.
what kind of crazy scenarios could we be looking at?
Well, some theoretical models,
Okay.
and I'll emphasize that they're highly speculative,
Sure.
but they suggest that if dark energy intensifies,
Okay.
it could eventually rip apart galaxies, stars, even atoms themselves.
Whoa.
Yeah, it's pretty intense.
That's
This hypothetical event is often referred to as the Big Rip.
the Big Rip.
Yeah.
Okay, wow, that's a pretty intense name.
Yeah.
I can't even begin to wrap my head around the
Yeah.
universe disintegrating
Right.
at its most fundamental level.
It's definitely a mind-boggling concept.
It is.
But it's important to remember that these are just theoretical possibilities
Right.
based on our current,
Yes.
still limited understanding of dark energy.
Right.
Further research is needed
Yeah.
to determine whether these scenarios are even remotely plausible.
Well, that's the beauty of science, right?
Absolutely.
Always pushing the boundaries of knowledge.
Yeah.
Refining our understanding of the universe.
Always searching for answers.
Yeah. It's like we're piecing together an enormous cosmic jigsaw puzzle.
It is.
And dark energy is one of the most crucial missing pieces.
I agree.
Yeah. And just as understanding, gravity led to incredible technological advancements.
Right.
Like GPS.
Exactly.
Who knows what doors unlocking the secrets of dark energy might open?
Exactly. It could completely revolutionize our understanding of physics.
Yeah.
And lead to innovations we can't even imagine yet.
It's all just so incredibly fascinating. From the accelerating expansion of the universe to the mind-bending possibilities of vacuum energy quintessence and even cosmic cracks. This deep dive has truly been a journey of discovery.
I couldn't agree more.
What started as a seemingly simple question,
Right.
what is dark energy,
Right.
has opened up a Pandora's box of cosmic mysteries and scientific intrigue.
It really has.
So what does this all mean for you? As we wrap up this deep dive, what questions are swirling around in your mind?
Yeah.
Are you intrigued by the vastness of the universe and the enigmatic nature of dark energy?
Hopefully.
Yeah. Do you find yourself pondering the ultimate fate of the cosmos and our place within this grand cosmic tapestry?
It's definitely something to think about.
It is. Remember, the pursuit of knowledge is an ongoing journey.
It is.
We've only just begun to scratch the surface of this cosmic enigma.
Right.
Keep exploring, keep asking questions, and who knows?
Yeah.
Maybe you'll be the one to make the next groundbreaking discovery about dark energy.
I hope so.